Good morning. Here we are to present to you tangential components of acceleration. Next, please. First off, acceleration can be broken down into two parts: the normal acceleration and the tangential acceleration. The tangential acceleration is the one who is tangent to the curve, and the normal acceleration is the one who is perpendicular to our tangent line. Here, tangential acceleration is equal to the derivative of velocity or derivative of time. And the normal acceleration is equals to velocity squared over the radius of curvature. And we have here our velocity that can be located any point here in our curve. Next, our radius of curvature, which is represented by a rho symbol here. And finally, our acceleration, which we have a formula of the square root of tangential acceleration squared plus normal acceleration squared. Here we have a problem on tangential components of acceleration. I'll read it first. A motorist traveling on a curved section of highway of radius 750 meters at the speed of 100 kilometers per hour. The motorist suddenly applied the brakes, causing the automobile to slow down at a constant rate. Knowing that, after 8 seconds, the speed has been reduced to 75 kilometers per hour. We'll have to determine the acceleration of automobile immediately after the brakes have been applied. Given that, we have our radius of curvature is equals to 750 meters, and the speed, which is equals to 100 kilometers per hour. Take note, it's our initial speed, initial velocity. We'll mark it with VO. And we have a instantaneous velocity after the brakes have been applied, which is 75 kilometers per hour. And the time, which is 8 seconds. And we're finding for the deceleration after the brakes have been applied. Or we'll mark it as acceleration. Since we have this formula of acceleration is equals to square root of tangential acceleration squared plus normal acceleration squared. We'll have to find for these values first. And first, we'll have to convert our velocities from kilometers per hour to meters per second. VO, which is 100 kilometers per hour. Kilometers. 1 kilometer is equals to 1,000 meters, and 1 hour is equal to 3,600 seconds. Simplifying, we have 100,000 meters over 3,600 seconds. Simplifying again, we have now our initial velocity of 27.78 meters per second. Next, our velocity, instantaneous velocity, which is 75 kilometers per hour. Canceling kilometers, hours, 1 kilometer, 1,000 meters, 1 hour equals to 2,600 seconds. Simplifying, meters and 3,600 seconds. Simplifying again. We have now our velocity is equals to 20.83 meters per second. After solving for our velocities, converting it from kilometers per hour to meters per second, we can now solve for tangential acceleration. We have the formula of tangential acceleration is equals to derivative of velocity over derivative of time, which the derivative of velocity is equal to instantaneous velocity minus initial velocity over change in time. Substituting the values, velocity of instantaneous velocity, which is 20.83 minus the initial velocity, which is 27.78, both in meters per second, and our time is equals to 8 seconds. Simplifying, subtracting 20.83 minus 27.78 is equals to negative 6.95 meters per second over 8 seconds. Simplifying, and we have now our tangential acceleration, which is equal to negative 0.868 meters per second squared. We have now our tangential acceleration. Next, we're going to solve for normal acceleration. In normal acceleration, we have this formula of normal acceleration is velocity squared over the radius of curvature. We let our velocity is equal to our initial velocity. Substituting the values of initial velocity, which is again 27.78 meters per second over the radius of curvature, which is 750 meters. Simplifying, our normal acceleration is equal to 1.02 meters per second squared. Then we have this normal acceleration. We can now solve for now for what we're finding. On the first place is the acceleration. Acceleration is equals to square root of tangential acceleration squared minus plus normal acceleration squared. Substituting the values, of tangential acceleration is 0.868 negative meters per second squared plus 1.0 meters per second squared. Simplifying, we have now our acceleration of 1.35 meters per second squared. Then we have now our acceleration due to brakes, or what we call deceleration, of 1.35 meters per second squared.